Okay, so today I'm going to talk about reproducible research. And as Anita said, I'm Kirill Shmidt, senior analyst at Wrike. And I want to discuss this topic because it's kind of cornerstone in the work of the analyst. So have you ever encountered a problem that you actually can't repeat work that you have done a couple of months ago because data is lost, or maybe process is too complicated and you can't make it again in the same way, so you can get same numbers in your reports, and that's kind of frustrating because you can't even be sure that everything was done correct in previous research, and how can be assured that your next research will be correct too. So first of all, a couple of words about me. I'm senior analyst at Wrike, and I work in analytics for more than 7 years, worked in different industries. I joined to the Wrike team recently, a couple of months, and I worked in medicine, in banking software, at networks, and now I'm working in project management too. And also I'm leader of community, SPB, St. Petersburg Business Intelligence Community, where we discuss similar problem, but generally offline in our city. So what is the main job of the product analyst at Wrike? Product analyst at Wrike, like right hand of the product manager. So we are very focused on understanding clients' need, our customers' needs, how they use our product, what we can do better for them. And as product analysts, product managers is people who actually drive products. But if they want to understand what's happening, they usually need help of us, of product analysts. So we help them to understand needs, to find relevant metrics, how to actually measure what we do, and actually understand have we done everything good, or maybe we made some mistakes, or maybe we need to do these actions instead of something other actions. And we perform A/B testing to ensure that everything that actually things that we have done influenced and affect of clients' behavior. But as a product analyst, we actually try to find out truths about clients' behavior, so some kind of objective truths. And in this sense, we work as a kind of scientists. They do the same way. They try to find objective truths about nature, and we as a product analyst try to find objective truths of clients' behavior. And we share same methodology with scientists in this way. Now it's very popular among product managers, hypothesis testing. So we want to formulate some kind of idea and then test it. Does really our clients like it, or is this hypothesis right or wrong? And this corresponds to the second idea of the scientific method, that our hypothesis should be falsifiable. And eventually we need to understand, is our idea correct or wrong? It can be, we shouldn't generate ideas which can be proven wrong. Third idea of scientific method is that we need to pass peer review, so other people can see what we have done. We should discuss it, so we can find problems, and we should develop our understanding of the objective truths, reality, or our needs of our customers, so we can gradually develop understanding as it happens in science. And one of the important point is that we actually need to be able to repeat this many times and get the same conclusions. So if we have same amount of data, if we have starting amount of data, we need to get to the same conclusions, and these conclusions shouldn't depend on the researcher who actually performed the research. Otherwise, we actually seeing results of research interpretation rather than objective truth. So reproducibility is this a way to fight against subjectivity of the researcher. And also it's a way to be ensured that everything was done correct, so peer review can be effectively performed, because you can see actually on the process how research was done. And this reproducibility, despite the fact that many work of the analyst looks like scientific work, actually it's performed in a slightly different way. So I want to describe my example from my experience. Then I was young analyst. I mostly work in Excel actually to perform all the analytical duties to transform data. And one of my requests from the stakeholders was about performing churn analytics of the clients. I worked for banking software company which developed software for prepaid cards, and developed this product. And my task was to analyze churn rates for clients with who had mobile application, who meet some kind of threshold of monthly turnover, and who had credit products on their prepaid cards. So actually, to do this, the typical steps of this procedure is to gather data from different resources and different sources, and these sources wasn't organized in nice and tidy database. It was spread across the company. So I actually need to gather different files from different places, then ask for the data from different people. Then I need to hard process them in Excel. So I need to shuffle some cells between each other to create some formulas, calculate many things in a manual way to actually join all the data and pre-process it, filter clients which I need for the research, and eventually build up report as an email which I send to my stakeholders. In this email, I copy and paste data from my data sources and my prepared data sources. Copy and paste all the graphics, and eventually we discuss the results with the stakeholders. So that's a typical process of ad hoc research, but still it's already very laborious. It took lots of effort actually to do so, and then we after review we find out that we need to go deeper and modify some details in this research. And here we come to the big problem, because actually to modify all this work, it's a huge problem. Because it was done in Excel, it's very hard to actually replicate all the steps which was done to achieve the result. And even if I can repeat it, it will take lots of boring and routine work to rebuild report and to rewrite all the conclusions, even if I change very small amount of data, and if focus of my research change really slightly. So the issue arises with the reproducibility arises, then you need to modify or extend your research, which was already done. Then you need to recheck your data or conclusions. Then somebody point out for some kind of problem, inconsistency, or maybe to unexpected numbers in your reports and researchers. Then you need to return to your research done a couple of months ago, and then you forgot how it was done. You have a bunch of files, a bunch of data, a bunch of reports, but you do not have actual links and connection how to work through it from the beginning to the end. And actually, it's hard to perform peer review. So it's hard for other colleagues go deep into your research. They can read your report, but it's hard for them to go through all of your steps of the data preparation and data modification, which lead to your report and to your conclusion. So your peer review can be really deep. And it means that quality of peer review can be not so great. So how can we address this problem? Oh, and also, all this lead to cost to organization. So I described routine, I described this overhead, then you need to do additional work just to figure out what was done a couple of months ago. It may lead to inconsistency into your reports. Then same stuff done in different way, it produce different numbers. And different numbers in final conclusions and reports may lead to distrust to the analytics from stakeholders' point of view, because they think that you always do some mistakes, but maybe you don't do any mistakes, you just have shifting methodology. And if you have distrust in analytics, that means that your analytics isn't working for your company at all, because no one uses it for actual decision making. How can we address this problem? So I think that here we have two ideas. First of all, we need to tune yourself on special mindset about our work, and when we actually can implement some principles to actually do our work in more reproducible way. The mindset, it's about think about your work as work independent from the researcher. So like you are doing it not like it's work which is done by abstract researcher. So it should be repeated without you, and it should be able to understand it by other people. So you need to build up your research in this way from the beginning. This leads to ideas that you shouldn't use some kind of magic numbers, or maybe some kind of transformation which other people can't understand and only you can understand. And this also means that you should follow some kind of ideas in your work process. And what's the ideas we can implement in our research to actually ensure that we have reproducible research? The first idea and first principle is that we should try to do everything in code. It begins from extracting of data. First of all, try to use formal queries to actually extract data and save them in your research folder. For example, for my analytical experience, for this case with churn rate analysis, I should gather data in, I should store it in some, I should gather data through SQL queries wherever possible and save this in the folder. Also, it is very valuable to store your ETL transformations which you perform on data which you received as a script too. So anyone can repeat it again because this script actually represents what you have done with your data rather than words which you can write in your research as description of your data transformation. And also it's a good idea to generate all your outputs and graphs for your research in code, so you can regenerate them if if you need to change something and if someone wants to repeat your work. I want to show you example of this organization of files and all in code procedure principle. So here we have example of the research project which organized in a way that every step is stored in as a script. So here we have SQL file which extract data from the databases. This script downloads data to this local machine because it's more convenient for this research to store this data locally. It's small amount of data and it's easy to handle this in this way. And here we have a file which actually generate this file perform ETL transformation of the data and generate final report. And here we have final report, which I can send to the stakeholders. So everything from the beginning to the end done by these files. And if I want to modify something, I can just modify these files and every step. So if I save all these files, then I won't lose any step of creation of the report, and it will be reproducible. But we also have a couple of other ideas. Still, if you do everything in code, you will get to some level of reproducibility, but you also should ensure other things in the work process. And the second principle is use version control for your code. So if you created code, and then it's a good idea to actually store it as if it was a program, like it's done by professional programmers. So use GitHub and use version control, because it gives you ability to store your master version of your research, and you can always you can modify this research in controlled way, because version control system don't allow you accidentally to break your master version. It allows you to change history of allows to trace history change of the researchers. It provides you with backup version if you accidentally destroy your code on your local file or local system. And one of the advice: do not store data in repository, because you don't need it actually, because you can regenerate it using your code, so you don't need to store it in version control system. So code version control greatly helps you to organize your work in reproducible manner. So other idea is that third principle is about data control. Despite the fact that I don't recommend you to store data in version control system because it's not for it, but you need to be ensured that you get same data every time you're performing your report. So you should explicitly control things which depends on data, on date. For example, you may obvious example is date range. Then you'll get data from starting from this period to this period. Very often we use something like very often in scripts we use something like give me all data before January 1st of 2020. But this approach will lead us to a situation when rerun of your report will generate different data just because you have different period in your results of your queries. So it's better to explicitly control data ranges in your scripts and control of all variables which have time dependency. So which can, if you use some kind of current situation, then it's usually a good idea to save date of report generation explicitly in your scripts. And next idea is that you shouldn't depend your research on your locally saved data, because this will present huge problem for other people to reproduce it, because they won't have your data, and you need to move it to them, but you can also lose it because it's stored on your local machine. And you should be able to regenerate your data from your queries. But sometimes we do not have this ability because, because we got our files from different sources, not from our databases, because someone sent us this report or data source. And it's a great idea to actually store them at least in cloud, something like Google Drive, or if you can put it into database, then put it into the database so it can be backed by database procedures. And for principle is integrated reports. So integrated reports is notebooks. One of the examples of the integrated reports is R notebook or Jupyter notebook, which allows you to write reports and code in same file. So their features is ability to hide code from reader. So you can actually have code in the file, but you can hide it if you don't want to show it to the reader. You can write, if you use integrated report, you can write your research as a story. So you write words about your research, and then you decided to make some back and forth investigation of your data, and you can do it right in your report, just as a bunch of code, and then you figure out what you need to show, and then you can continue to write words about your report. So you are writing story from the beginning to the end. You do not create your research and your conclusions separately. You create it as a one unit. Also, it allows you to perform inline calculations and insert actual numbers in text. So if you're calculating some kind of, you may create some kind of string in which you're saying our conversion rate for this experiment is, and then put number which is actually calculated from the data from your research. And if you modify it in some way, this number will be recalculated for your integrated report. So this small adjustment would automatically change your output. So, and also integrated reports allows you to show and print graphs based on data in the same way as the inline calculation. You can control your output format. You can put it, you may create PDF files or HTML files or something different if you want. So you can separate you just can send to the stakeholders final report and simultaneously save all the prerequisites to reproduce it for the different peers or for some modification for the future. Well, in this sense, I prefer R notebook rather than Jupyter notebook because it stores. Because it's stored as a plain text rather than HTML code. But you can do all this stuff with Jupyter Notebook too. And I want to show an example of this with R notebook. So here we have actually integrated report in RStudio. So here we have title. R Markdown is used to write main text and to modify it. Here we have cell code and its output is a graph. So it's just a report. And eventually I can transform it to the HTML file. So here is the example. So this is the code in IDEA and this is the output for the reader. So I don't have this part with the code. I just have text, which is formatted in a way which is consumable by the reader. And I have graphs which generated from the code inside the integrated report. And I can send this to the stakeholder, and this file can be saved into version control system. So back to the So summary of the 4 principles for reproducible research. We should write everything in code. We should use version control. We should control our data, and we should use integrated reports to generate our results to stakeholders. And if we talk about workflow, how will be organized everyday research with these 4 principles. So you will begin from version control system. So first of all, you try to synchronize your master version with the cloud version control. Then you create your own branch of the, so you can write new research and don't mess up with the master version. Then you write your SQL files for data extractions, some scripts for data download and ETL. Then you start to write your integrated report and eventually generate report for stakeholders, push and commit your code to the version control system, and send generated report to stakeholders. So in this way, you will get everything stored in a reproducible way, and eventually you completed the tasks which was asked from you by your stakeholders. So thank you for your attention. I'm ready to answer your questions.
So, hi, I'm Kate. I'm product analyst at Wrike too, and today I will present questions to our speakers. So I want you to ask to join us in our Q&A live sessions that you can find like on the right sidebar near the video stream. And unfortunately, we don't have like a lot of time for questions, but I see one question, and it's from Sergey, and he asked, how do you send HTML reports to your stakeholders? And probably I can like add my own question to it, like, isn't it complicated for stakeholders to read your report like with code?
So the main idea is state. Yeah, this thing. So it's just document. So there's no code. It's just report. And this variant is knitted to the HTML format. So for them, any browser can open it. But I can alter result as a PDF, so they can read it as a PDF file. I haven't experimented with different formats, but I can knit it to Windows documents, and I think in Google Documents format too. So actual output is it's variable to your particular needs. So the main idea is there is no code for stakeholders. They don't need to see it. You can always hide it.
So yeah, thank you. So, and we have like a time for another question. So a question from Alexander, like ETL realized through standards, sorry, DPLYR library. Sorry, I don't know exactly this library. So probably maybe you can tell us more about ETL process. So.
Well, dplyr, I think it's a library for R. I prefer data table, actually. Well, so yeah, I think that how we actually can transform data using R or Python is a topic for other discussion. So how can we use these instruments like Python and R to simplify work of the analysts? Just another topic. So, but eventually, yeah, you can do many things in R or Python script, and in many cases, it's more simpler to do it in R or Python rather than SQL, because in R you can have cycles, you can have step-by-step execution. But in SQL, you need to perform your transformation as one in one go most of the time. But on the other hand, if you have heavy computation, it's preferable to do them on database engine rather than your Python, rather than machine with Python or with R.
Mm-hmm. And maybe the last question: why do you prefer Python? And probably, is there the same way to prepare the same kind of report, but for Python? And why do you prefer R? Sorry.
R, yeah.
Yeah.
Well, maybe I prefer R because I was brought into this script analytics through the scientific community, and they prefer R more over the Python. And I think, I think I'm biased in this way, but I think that it's better for analytical purposes, because everything is like constructed for you in the beginning, in the minds of the creator of the language. So, but in terms of actual abilities, I think that they are the same. So that's just different of preference between the two different languages. And yes, you can do the same. You can perform the same idea with Python. Actually, you have Jupyter Notebook, which do the same. You have code. You have text, which can be edited with Markdown, and you have Jupyter Notebook cells, which can have code and can be calculated and draw the results. And as I remember, you can hide the code from the users. But also I have another experience I can use both languages in integrated report. So I have I created a report which download and transform data using data table and R language, and then perform natural language processing with NLTK and scikit-learn libraries from Python, and all this stuff done in one document. So it's an interesting idea just to combine best things from the both languages.